Hey, BC Calculus, this is Mr. Canfield. Today we're going to do Chapter 2, Integration by Parts. And the thing about integration by parts is it's our next kind of logical step. We learned U-Substitution. And if you remember, U-Substitution was essentially a way to reverse the chain rule. And it winds up being an incredibly powerful tool for lots of different situations. Integration by parts is a way for us to reverse the product rule. So I'm just going to go through and do a quick proof of this, because I wish I did more of these. You don't need to understand this proof to understand product rule. I could just tell you what it is and you would be able to use it. But let's say that y is u times v. Two different quantities, or two different functions multiplied together. Two different differentiable functions multiplied together. Well, normally I like to use y primes and stuff like that, but because of the certain manipulations that we have to use for this, I'm going to need to use dy dx. Let's take the derivative of both sides with respect to x. So initially, this function would be two different functions of x, which most of the stuff that we do, that's what it is. So if I was taking this derivative, well, first we would take the derivative of the first one, and we would get du dx, and then times v, and then plus u times dv dx, right? So what we're going to do is we're going to manipulate this a little bit, and we're going to, essentially, we're going to end up with an integral that is going to be manageable. So the first thing I'm going to do is I'm going to multiply both sides through by dx. So when we do that, I get dy is equal to du times v plus u times dv. And then we can slap integrals on everything. So if we do that, well, we know the integral of just dy like this. The integral of dy is going to end up being y, right? There's a plus c, but we'll ignore that for now. Then over here, we can rewrite this as the integral of v du, and we can rewrite this one. Oh no, this one's already in the right format. So what we do after this is essentially we're going to pick one of these, and the classic way that we approach this is we subtract this integral from both sides, and we subtract the y from both sides. Nope. I'm backwards. We leave this one alone. And we subtract the vdu integral from both sides. That's what I meant to say. No, it's what I should have said. I got flipped around for a second. So the integral of u dv is equal to y minus the integral of v du. And if you remember at the very beginning, we said y was equal to u times v. So I can say the integral of u dv is equal to uv minus the integral of v du. Now, what the heck does that all mean? Well, what this is going to let us do, is essentially integrate things that we couldn't integrate before. It might not seem like it at the outset, but we're going to be doing substitution here and replacing parts. And then we're going to be able to essentially rewrite an integral to make it look like this. And when I do that, I'm able to fill out the rest. So this integration by parts formula goes over really well, generally. Seems to work really well for people. So let's, as the internet tends to say, let's just jump into it. So our first example is take the integral of x cosine x dx. Okay, so what we do for this, you know, what our mode of thinking is, we go, okay, I've got two things multiplied together. How do I integrate this? Do I try U-substitution? Like, U-substitution generally is one of the first places I go with things. So if we were to try U-substitution here, though, the derivative of x is not present, and the derivative of cosine is not present. And if you remember U-substitution, that's kind of a requirement. Sometimes there's ways to play with it, but there's nothing here. So instead what we do is, I like to make a little table. I make my u, my du, and then my v and my dv. And we're not going to pick u and v. We're actually going to pick u and dv. So if you remember the formula, if you go back and look at the formula says nothing because it's off my screen. The formula says the integral of u times dv, that's like the derivative of v, essentially. So if we can take the antiderivative of one of these, that's going to be v. Now the thing is, I can take the antiderivative of either one of these pretty simply. And in general, picking u, you want to pick the one that when you take the derivative of it, it goes to constants, it goes to numbers. So like the derivative of cosine turns into negative sine, the derivative of that turns into negative cosine, the derivative of that turns into sine. It turns into this repetitive thing. So the one that you take the derivative of, you want it to eventually like cancel itself out. So the derivative of x is 1. So I know that I'm going to want to make u equal to x, and du is equal to 1 dx. If you remember when we would do U-substitution, it would be du dx. We'd multiply both sides by the dx. So that's going to be important for us a little bit later with these things. So let's see. Next, my dv, I'm going to call dv cosine x dx, because now I can integrate this to get back. And if I integrate this, then what I get is, let's see, if I take the derivative of sine, I get cosine. Oh, okay, yeah. I was like, maybe it's negative. But remember, the derivative of sine gets us cosine. And I don't need a dx anymore. I guess, you know, technically you could have a plus c, but we're not worried about that right now. So if you kind of missed where some of those pieces came from, you know, maybe rewind and double check again. But you take the one that you can take the derivative of and make it go away, that's u. And then the other one's going to be our dv that you're going to integrate. So now I like to be very careful and write my formula before I go and put stuff in. I just don't want to misplace any pieces. And I'm actually second guessing myself. I just want to double check to make sure I didn't make any silly, because I made a silly mistake earlier in the video. Yeah, okay. So here we have our formula. So let's just put all the pieces where they belong. U was x, right? dv was cosine x dx. Then over here, u was x, v was sine x, minus v was sine x, and du was 1 dx. Okay, big deal. Well, the big deal is, like, what we just did was we rewrote this as something that we can actually do now. Oh, plus c, right? Well, I guess we're going to integrate this, and then we can put the plus c on, but whatever. So x sine x, wait, this says minus sine x. What's the antiderivative of sine x? Well, it's cosine x. Oh, no, not cosine. It'd be negative cosine. So this is going to be plus cosine x plus c. And you might look at this and say, well, there's no way that this is the actual antiderivative of the of that there.